We're now continuing our coverage of the benefits of combining object-oriented and functional programming in modern Java. In this second part of the lesson, we'll first outline the design and implementation of the ImageStreamGang case study to reflect these benefits, and then we'll summarize the relationship between object-oriented and functional programming. The ImageStreamGang case study, which is available at the link at the bottom of the slide, shows how to combine Java's functional and object-oriented features effectively. In the context of this case study, the domain intent defines the what, which in this case involves processing a list of URLs to images that aren't already cached, and then downloading, transforming, and storing the non-cached images in parallel. We then apply Java's functional programming features, in particular method references and Java streams, to implement computations that define the how. In particular, we take a list of URLs, convert it into a parallel stream. We then apply the filter intermediate operation to remove cached images. We then apply the map operation twice, first to download the images in parallel, and then to apply filters to transform and store the images. And finally, we use the reduce and collect terminal operations to collect the results into a list that will be displayed to the user. This case study illustrates how Java's functional programming features connect the domain intent and computations by aligning them so that the what, which is the domain intent and the requirements, are reflected cleanly in the implementation of the computations that define the how. The ImageStreamGang case study also shows how an object-oriented software architecture helps to enable systematic reuse, which is an institutionalized, organizational approach to product development in which reusable assets are purposely created or acquired and then consistently used and maintained to obtain high levels of reuse, thereby optimizing the organization's ability to produce quality software products rapidly and effectively. For example, the ImageStreamGang case study defines some common superclasses that provide a reusable foundation for extensibility, such as the ImageStreamGang class that extends the StreamGang superclass to use modern Java functional programming features that download a list of images from remote web servers, apply image processing filters to each image, and store the results in files that can be displayed to the user. Subclasses extend these common classes to create various custom implementation strategies. For example, the ImageStream Parallel class extends the ImageStreamGang superclass to use Java's Parallel Streams framework to download, process, and store images in parallel. Likewise, the ImageStream Completable Future 1 class extends the ImageStream Completable Future Base class, which in turn extends the ImageStreamGang superclass to download, process, and store images asynchronously using the Java Completable Futures framework and the Java Common Fork Join Pool. Java's object-oriented programming language features, such as inheritance and dynamic binding, make it possible to extend the existing superclasses, thereby adding new capabilities to the framework without perturbing any of the other code that exists. In other words, these extensions can be done in a way that's transparent to the rest of the software. Java's functional programming features are often most effective when they're used to simplify computations within the context of an object-oriented software architecture. In particular, the ImageStreamGang case study illustrates how Java's functional programming features help to simplify the composition, extension, and reasoning about the behaviors to implement the various strategies, whereas the object-oriented programming features help to simplify the composition, extension, and reasoning about the structural part of the software architecture of this case study. This combination is especially important for concurrent and parallel computations that can otherwise incur various concurrency hazards, such as race conditions or memory visibility problems, which are particularly hard to identify and rectify when programs aren't structured in a coherent object-oriented manner. This has just been a quick walkthrough of the ImageStreamGang case study. We'll examine this example much more extensively in upcoming lessons. So let's go ahead now and summarize the programming paradigms in modern Java. Combining the functional and object-oriented programming paradigms in modern Java yields several benefits. We showcase these benefits in the context of the ImageStreamGang case study explored earlier in this lesson. The functional programming features in modern Java help to simplify computations by applying function composition, which focuses on the what, not the how, and thus better aligns domain intent with computations. The object-oriented features in modern Java enhance systematic reuse by defining abstract classes that provide a common foundation to leverage the structure and functionality of existing code. These object-oriented features also enable transparent extensibility via inheritance and dynamic binding that allows the addition of new customized capabilities without perturbing the ones that already exist. Michael Feathers has a nice quote that he put on Twitter a number of years ago that talks about how object-oriented approaches makes code understandable by encapsulating moving parts, whereas functional programming makes code understandable by minimizing moving parts. So let's take a look at Michael's quote in the context of the examples we've looked at so far. Java's object-oriented programming features makes code understandable by encapsulating the moving parts. And we saw that in the implementation of case study EX0 in the FP directory in my modern Java GitHub repository, where the implementation details of the zap method are largely encapsulated by Java 7's reusable classes and the traditional control constructs you know and love in Java, such as for each loops and if statements. In contrast, Java's functional programming features help to make code more understandable by largely eliminating the moving parts. And once again, we saw this in the EX0 case study when we looked at the modern Java implementation of the zap method, whose implementation avoids explicit use of Java's control constructs. You can see here we've largely eliminated the moving parts, whereas the previous implementation emphasized those moving parts, even though they were encapsulated. So that wraps up the second part of our lesson, talking about the benefits of combining object-oriented and functional programming in modern Java.